Hi everyone, welcome back to the On Track podcast. Today we have the distinct pleasure of sharing Steve Sandler with you, who's the Managing Director of Picotest. Steve is a world-renowned expert on test measurement in regards to signal integrity, power integrity, and EMI. He'll talk about what he's going to be teaching at DesignCon this year, as well as give us some resources that we can share with you where you can tap into his books, webinars, and so much more. I'm sure you're going to enjoy this rich resource and Steve Sandler. Enjoy. Welcome to Altium's On Track podcast, where we talk to leaders about PCB design, tackling subjects ranging from schematic capture all the way to the manufacturing floor. I'm your host, Judy Warner. Please listen in every week and subscribe on iTunes, Stitcher, and all your favorite podcast apps. And be sure to check out the show notes at altium.com/podcast, where you can find great resources and multiple ways to connect with us on social media. Hi, Steve. It's so good to see you. Thank you so much for joining us on the On Track podcast today.
No, it's my pleasure. This is fun, so I'm ready for it. Let's go.
Well, I've been sort of cyber stalking you, I think, for a lot of years. I'll have to check it out. We've been connected for a long time on LinkedIn, and so some of your stuff comes up in our feed. And I knew I always wanted to meet you, but didn't really follow up until now. So it's a pleasure to meet you, and I can't wait to share you with our audience. So tell us a little bit, Steve, about your background in the industry and sort of how you got to where you are today.
Sure. So I guess I've been around since the time of the dinosaurs. I started in the
Me too.
I started in the 1970s, and I was very fortunate. The very first project I got to work on was the space shuttle, and I worked on the space shuttle for about 6 years, and from that time I was hooked on aerospace, and so I've worked in space almost exclusively since the 1970s. Wow. But one of the things I found is I really didn't like working for bosses. I don't take directions well, and my interests kind of wander.
Yeah.
And so some people had a hard time getting me to focus. So I actually started my first company, and it was about 1985. And I wasn't even sure what I was going to do, but my dad believed in me. He mortgaged his house, and he gave me a bunch of money. And he said, go figure out what to do. And I started a little tiny company called Electronic Innovators. And we did custom kind of consulting for mostly local companies. And I did that for a while until maybe the 1980s. And then in the 1980s, I got back into mostly military and defense. And I worked on the F-16, and I worked on the B-52, and the SR-71, and all that cool stuff. And I had a blast. And I kind of hung in there until like the 1990s. And then I just got fidgety again. I was like, I just can't be working for a boss. I just don't like that. And so I started a company called, it was called AEI back then, Analytical Engineering. And similar kind of thing. I did modeling and simulation, mostly for the aerospace community. And I was pretty good at simulation. I wrote my first book in 1996, and it was about simulation. And then people started working on the International Space Station, and they asked me to help. And I said, I kind of got this business going, and I'm kind of liking working for myself. Yeah, and they kept asking, and I kept saying no. And finally, one morning, I woke up. I had a fax machine in my bedroom, and I got a fax that they contracted me as a consultant for 4,000 hours. And it came with a note saying, there's more than one way to skin a cat. Now you work for us.
Nice.
And so I started working on the space station, and I just overheard a conversation. NASA was visiting, and they were talking with Space Systems Loral, the contractor. And they said they just didn't know how to do modeling and analysis of something as big as a space station.
Wow.
And so I left for the Christmas holiday. I wrote an unsolicited proposal, and I won. And to this day, I can't tell you if that was a good thing or a bad thing. I'm not sure. I can tell you it was a very intense 7 years, at the end of which I retired.
Wow.
That was a very, very intense 7 years.
Was that your exclusive contract? Were you working exclusively on that, or did you have
No, I had other contracts too. I worked on GPS, late 90s. They had a problem with the accelerator at CERN, and I don't know if you remember that, but they tried to start the accelerator and it didn't work. And they called me to see if I could figure out why. And I did. It only took me 6 weeks, and I got the accelerator started for them. And everybody was really excited. And at the time, my younger daughter was studying physics at University of Arizona, and she happened to be working on the calorimeter. And one day, I ended up working with my own daughter, which was pretty cool because it wasn't planned. She was working for U of A, and I was working for the Department of Energy. And I just ended up working with my own daughter one day. That was pretty cool.
Oh, that's fun.
But I've worked on, almost every satellite now. Analytical engineering became AEI systems in the, I guess about at the onset of International Space Station. Right after that, in 2000, I retired. And I sold the company to my best friend. And he said, do me a favor. He said, I just need you to stay on as the CTO until I find your replacement. And to this day, I'm still the acting CTO of AEI Systems. And every once in a while, I ask him, how you doing in finding my replacement? He said, very slowly, really slow. So I'm still their CTO, the acting CTO. And he's actually a partner in Picotest now also, which is cool. Which is my new company. So like I said, I retired in 2000, and I pretty much took 5 years off, and I traveled around the world with my daughters. I have 2 daughters, and I took them all over the world, and we had a blast.
Awesome.
Then I got bored and decided it was time to start another company. So I started Picotest in 2010. And that's been a fun run. It's growing and it's fun.
So tell us about Picotest and what inspired you to start that particular company and sort of the need you were filling there.
So honestly, at the time, I wasn't really looking to start a company. I was looking to do something. I had just gotten remarried. My wife was going back to school, and I was used to traveling around the world. What am I going to do now? I'm kind of stuck at home. And I said, I know what I'll do. I'll write another book. And I thought, I never wrote anything about RF, so I should write an RF book. And I started writing this book. And while I was making these measurements, I kept getting frustrated because whatever I needed, I just couldn't seem to find. I had all these instruments, but I didn't have anything to connect the instruments to the boards, And I said, somebody has to make this stuff. I'm gonna make a company that makes this stuff. And I ran into a company online that's called Picotest. They're in Taiwan. And my wife and I jumped on a plane to go meet the people in Taiwan and see if we liked them. Because I have a very basic rule. I won't do business with anybody whose hand I didn't shake. And so if I didn't meet them and talk to them in person, I won't do business with them. So we jumped on a plane and we went to Taiwan. And we talked to him about these products we want to make. And he wasn't really very excited about it, but he said, I'll do it. And we had this weird negotiation because he kept telling me he wasn't going to do it unless I took most of the money. And I said, well, I'm not doing it unless you take most of the money. And so we fought for about 2 days over, who's going to take the most money. We finally came to an understanding that neither one of us loved, but we could both live with. And he said, I don't even understand these things you want to make. And I said, so why are you going to make them? And he said, because you're my friend and you asked me to.
Oh, nice.
And I said, wow, okay, so let me make you proud. And that's how we ended up with the name Picotest. We're not related to the company in Taiwan, but I said, nobody ever heard of Picotest in the United States. And I said, I'm going to try and help you. So he gave me the trademark to the name Picotest, and we use it just to help them.
Oh, I love that story.
Yeah.
I love, my friend Tara Dunn and I, we've talked about how much the thing we value most in this industry is the relationships that we've built over the years, right? And so we always sort of joked how we wanted to launch a company that sort of greased the skids, right? And we wanted to call it the human element of technology, right?
Oh, that's cool. I
know,
like that.
Right? And I think that it gets overlooked sometimes, but I love that story because it is the human element that really makes things go. So before we get started on some of the incredible things that I'd love to hear from you on, which is signal integrity, power integrity, and EMI, and sort of so much you have to share there, I wanted to have the listeners get a little sense about DesignCon. First, for those that have never been there, what the value is you see in the show in general, because I know you've been part of it for so long. And then also I would like to hear about the presentations you'll be giving and,
sure.
Kind of whet their appetites maybe to come see you.
Sure, that'd be great. So, I have been involved with DesignCon a long time. I'm on their editorial board, and there's so many things that I tell people you really have to go for. But it's like you said, it's the people, right?
Yeah.
Where else do you get to go talk to Istvan Novak and Eric Boganen and Lee Ritchie and Al Neves all at the same time?
Yep.
It's like the who's who, and everybody's running around sharing what it is that they know. For me, I like DesignCon because I like teaching. And, maybe you can tell from the gray hair that I'm not so young anymore. And when we're young, we're really very ego-driven. And now I realize I'm getting towards the end of my career. I want young people to start where I ended, not where I started. So I want to make sure that I teach them everything that I know. And if they're interested, I'm teaching them. And so at DesignCon, I think there's this incredible universe of knowledge with people that are so willing to share it, and I think that's really valuable. And you'll see there's also many programs for young people to connect with people like me. And I'm involved with every one of those projects. All of the new greatest tools and all the manufacturers are there. And a lot of our projects, we ended up finding manufacturers either, at DesignCon or through one of the other shows. But DesignCon is probably the biggest for high speed, SIPI and EMI, I guess what we call the trifecta.
Mm-hmm. Yeah, it's so true. I love that show. And it's definitely, that's where I met Lee Ritchie, Eric Bogatin, and I came to learn about Yuri Shlepnev and Siberian, and Bert Simonovich. You know Bert?
Oh, I know Bert really well.
I love Bert.
I know Yuri really well. Bert's one of my favorite people. Every time he talks, he goes right over my head. But Yuri too.
I know.
The things that Yuri does, they're just crazy. But he's nice. He's a really nice guy, and he's very smart. And even people like Pavel Zivny and they're all really nice, and they're all happy to share what they know. And I really like being part of that.
Yeah, it's true. The community aspect of that, and unless you just put your hand out to shake. Yeah, I think it's easy to go, I've heard this, in the elevator. Yeah. Oh, there's Eric Bogatin, or there's Lee Ritchie. I'm like, just reach your hand out and shake it, and then they won't stop talking.
I have to tell you, one day I was teaching a class at DesignCon, and I saw Eric sitting in the audience, and I was like, "Oh my God, you're not going to do this to me! You're not going to do this to me!" And he said, "Steve, I'm going to learn power integrity from you. I'm a signal integrity guy, not really a power integrity guy." My knees were shaking, and not long after that, I went to one of his sessions, and he saw me, and he has this big bag of chocolate in front of the room all the time, and he threw a bunch of chocolate at me, and he says, "That's a prepayment, not to haggle me."
That's hilarious. I know. I love his habit of chocolate throwing.
Yeah.
So what are some of the courses you're going to be teaching this year, Steve?
Yeah, I have a lot of them this year. So most years I do a power integrity Bootcamp. Excuse me. I'm doing it again this year. With Heidi Barnes from Keysight and Jack Carroll from Xilinx. And it covers power integrity, signal integrity, all the way from one end of the board all the way to the other. It's a full day session, and it's just absolutely great. In fact, everybody actually has live simulation in the room. Keysight has ADS for everybody.
Wow.
And it's nuts, absolutely nuts. And I don't know if you know this, but I'm one of the 80 worldwide certified experts in ADS. So I spend a lot of time working with Heidi, and it's just so much fun. But it's all day on Tuesday.
Wow.
I have a session on measuring oscilloscope voltage probes because I said that most people don't know how to measure them or calibrate them, and in fact, in a lot of cases, it can't actually be done because the calibrator signals that they use aren't really up to the task. And so we built a gallium nitride probe calibrator, and I'm teaching a class on it, and we'll be showing 2 ways to accurately measure scope probes. I usually do an industry session. This year it's with Tektronix. I kind of work with all of the instrument companies, and this year it's Tektronix on introduction to power integrity. And then I have sessions with the young people. I have one called Jumpstart Your Career, for people that are trying to figure out when they're starting out, why did I start my own business and how do you do that? And, how do you become a consultant and how do you, learn what you want for your job? And so I'll be part of that. And then I'm part of Eric's panel on Stump the Expert.
Oh, yeah.
That is going to be great because it's me and Isfan and Eric. And we did that a couple of years now. We've all been on the same panel, and that's always fun. So we'll be doing that one. And then I think I have one or two others also. So I'll be busy for sure.
Well, I'm going to come for sure to the Stump the Experts one. So I want to meet Istvan and Larry, and I don't know who else is on the panel. So I
can introduce you to Istvan.
Okay, good deal.
Great.
Yeah. So so I will definitely come in and check on you guys there because, oh my gosh, what a heavy hitter panel, man. Anything you wanted to know, I feel like you get answered there. Yeah. So now, you've been in this industry a long time, as have I, but what have you noticed sort of over the course of your career, sort of how things are changed, how they used to be, and sort of how they are now? And what implications that has on, what today's busy engineer, right, needs to know and take on regarding all three of these things?
That's a really great question. Let me tell you, back when I started learning ADS, it was before I started Picotest, and I just needed something. I knew I needed something. I was going to write an RF book, and I said, everything seems to be getting faster and faster. I need to learn about RF. And I bought a copy of ADS, and I was just going to go teach myself how it worked. And I think that the change has been really dramatic since then. It's maybe 15 or 20 years now. When I did the analysis and the modeling for the space station, every report I wrote had a disclaimer in the front that said, this doesn't include printed circuit board effects. And today I would say don't even bother, because it's all printed circuit board effects, DC, high frequency, whatever it is. And we have these conferences that talk about the big trifecta, SI and PI and EMI. And I'm always asking engineers, do you really think there's three kinds of electrons? Because I don't think so. I think there's really only one. And they don't really categorize themselves. I'm going to go be a PI electron, and you go over there and be an EMI electron. I mean, they just do whatever they want to do. And, so I've had the pleasure to work with people in different groups like Ken Wyatt, right, the EMI guru. And one of the things that I like to show is that the EMI that you're measuring, we can see in SI and we can see it in PI. We just have to measure it differently. I think where I see the most impact really is in the automotive world, and I spend a lot of time in Detroit. And people tell me all the time, Steve, we'll write you a blank check, big as you want, save us board spins. And I think that the problem today is that boards are really complicated, very high layer counts. Engineers are so overloaded. They're constantly trying to learn new measurements and new technologies and new simulators, and they really just want it to stop.
Totally.
They get a project and they tell me the only thing they know about their project when they get it is the day they have to deliver it. They don't know anything else about it, but they know the day they're delivering it. And I think this is really a big deal. And I'm talking about it a lot these days, and you'll probably hear a lot more about it in the coming year. I'm not ready to talk about where we're going. But I said engineers don't want more instruments. They don't want more traces on their screens. They don't know what to do with the ones they got. What they want is answers, right? Don't show me a pretty picture on a screen. Tell me what to do. And that's coming. That's coming. And I'm going to be a part of that. And I'm very excited. I think that's really the future. I think there's another thing, and I talked about this in my Designing Power for Sensitive Circuits series. Everything is interconnected with everything else. So most simulators today don't actually include the voltage regulator module. And that's one of my areas of expertise. And yet at the same time, that's the single largest source of jitter. So we're doing our jitter analysis without the single largest noise source. How does that make sense, right?
Wow.
And so I keep saying that I don't know if it's 2 years or 5 years or 10 years, everything will be simulated end to end. And that means you're going to have a power supply at one end and you're going to be looking at the jitter that it induced at the other end. And I actually did show that in my Designing Power for Sensitive Circuits. And we put power supply noise, from a real power supply model at one end. And we actually looked at the phase noise of the clock at the other end. Mm-hmm. And when you start to look at that, things start to make a little bit more sense holistically. One of the things that engineers struggle with, because it's so counterintuitive, is that the impedances on the printed circuit board don't always perfectly match, and there's kind of a pivot point electronically. There's this balance point that's the characteristic impedance of the plane. Mm-hmm. And so you got these high-speed guys saying, hey, the noise is way too high on my CPU. You guys really need to lower the power supply noise. So they make the power supply impedance lower. And then the high-speed guys say, this doesn't make any sense. The noise just got worse. And that's correct. It is. It's absolutely correct. And we teach that in our lectures and in Designing Power for Sensitive Circuits. I said, people think that voltage regulation is a great thing. It's not. It's really a terrible thing. And if we destroy the regulation of the regulator, it'll generally make our clocks better. And that was the whole theory of this Designing Power for Sensitive Circuits. And I really got, my Just Reward maybe 6 months ago. There's a nice young guy at Cray that's kind of a friend, Brian Hostetler, brilliant young guy. And he attended the paper, he read the articles, he watched the webinars. And maybe 6 months or a year ago, I got an email from him saying we had a problem with the clock distribution in our supercomputer. And just like you said, I fixed it with one resistor.
That's crazy.
And so I think this is the crux of it, right? I think that what's happening is engineers have become way too narrow, and they don't really understand how what they do impacts other people, and what other people do impacts them. And when you learn it holistically, everything starts to make more sense.
Yeah. Well, you and I talked about this before. We've always been in silos, right? It just didn't used to hurt that much that we were in silos, right? That you knew you could throw, whether it's chip, board level, whatever. Yeah. It used to, the complexity of the designs were such that it didn't really matter what you did on the board.
Sure. And now they're getting denser too, right?
And now everything. And, kind of to illustrate your point on my end, I just went to a class yesterday, a design group up in Orange County, and Jerry Partita from Summit Interconnect taught it. And this first slide was just a finger pushing down on a BGA. Yeah. And it was saying, does it work now? And he taught about via structures, right? And how there's this mysterious, IPC is doing this whole thing on via reliability, and this mysterious thing that's happening with, they don't know what it is, right? And so, anyways, it's like you said. I mean, people who are experts in some of this stuff are just frantically, they can't get the data fast enough, they can't get it out fast enough, and the left hand doesn't want to know. It's kind of a perfect storm, really.
Yeah, we used to just throw stuff over the wall and somehow it always worked,
and
right?
It did.
And I'll tell you something, I consult a lot, and one of the things that's fascinating to me is I'm always troubleshooting power integrity problems, and the power engineers never even show up. It's always the high-speed guys. The high-speed guys are always the ones that end up stuck with the problem. And in fact, I think it was about a year and a half, maybe 2 years ago, TI asked me to do a lecture in Dallas for them. Because so many people were asking them about power integrity, and they kept saying, Steve, we don't do power integrity, we make power supplies. And so I did a tutorial that was essentially titled, You Are Ground Zero, You're the Problem, which they didn't love, and a lot of it went over their heads, but they just don't understand that interface. And that interface is, it's a really critical interface. They are, the foundation of the noise issues. There's another thing that I say a lot, and I know that every time I say it, Eric Bogdan shakes his head, but I said, high frequencies never scared me, but low frequencies, those scare the hell out of me. And the reason is really simple. noise travels. It travels really far. If I were to just take a 1 kilohertz square wave, right, we know what the fundamental looks like, and Fourier tells us what the harmonics look like. But if you look at the edge of that, and we look at the harmonic structure, you're going to see signals every 1 kilohertz. And you're going to keep going all the way until you hit the edge speed, which could be, many gigahertz. Mm-hmm. And one great example I tell people that is the rubidium clock on the GPS satellite. It's a 13 megahertz crystal, mm-hmm. and they tap the harmonics of that to resonate the 6.9 gigahertz rubidium tube. So what harmonic of that is? I think even after the tripler, that's the 583rd harmonic of that signal that they're tapping off. You'll see we made a vector network analyzer for oscilloscopes that we'll be showing at DesignCon, and we also use it as a TDR. And we did an 8 gigahertz VNA using a 1 kilohertz signal. And that signal, once you create noise, it travels forever. And so if I take a 1 kilohertz pulse and I look at the harmonics, they're going to be a kilohertz apart. The likelihood of finding some resonance on the board within a kilohertz is pretty good.
Yeah.
What if I make them 100 megahertz apart?
Yep.
Now what's the likelihood I'll find something with 100 megahertz? Much, much lower, right? The lower I make the repetition rate, the more likely it is to cause noise trouble.
Interesting. I've never heard anyone say that. That's fascinating.
Yeah. Right, and you see that. We use some high-speed logic chips from Hittite, and one thing that was really interesting to me is I bought their little eval board, and it was ridiculous, like $1,100 for one chip with a couple of connectors on it, and it had one little ceramic decoupling cap and a place to connect banana clips. And I'm thinking, how is that going to work? The banana clips are pretty inductive. And it was so clear to me that they only looked at the 13 gigahertz signal. They never looked below that. I mean, at 100 kilohertz, this thing was bouncing all over the place. Nobody ever saw it.
Oh.
And if you go back 2 years at DesignCon, I did a paper with Heidi Barnes and Jack Carroll on one of Xilinx's evaluation boards. Mm-hmm. And they actually had that problem. They were looking at their, I think it was 28 gigabit transceiver in that 2018 paper. Mm-hmm. And they ended up having a problem, but the problem wasn't close to 28 gigabits. They couldn't turn on the transceiver without the low frequency ringing getting into their phase lock loop. And it was just, they were just so focused on that 28 gigabits, nobody looks at that low frequency stuff.
Interesting.
And so I think that paints this picture of this holistic vision that says that, you just have to have this crazy vision from one end all the way to the other, or things just don't make sense.
Well, beyond dealing with some luminaries in the industry, I also get the privilege to work with some students. And one observation I have, and I'm interested to know if you share this with me, is I think curriculums for EEs now at university is just missing a bunch of stuff in regards to what they're actually going to face in the marketplace and what they're going to be tasked to do. I mean, for sure, they don't learn PCB design.
No, it's missing a lot.
But I'm sure as far as instrumentation, power integrators, all these things, EMI, I know for sure they learn the basics, of field theory. But, every time Rick Hartley teaches a class, and me included, by the way, I remember when he taught the class and basically said, it's in the fields, it's not in the trays. Yeah, right. And I'm like, what? I sold circuit boards my whole life. I pictured the signal moving neatly through this network, right? Web. Yeah. And he's like, no. That's not how it works.
It would be nice if it did that.
Oh my gosh! And so he said that, but every time he teaches this to older engineers as well, but particularly their heads literally blow off, their scalp comes off, because they're like, I know nothing, and so I'm like, man, there's just such a disconnect. So do you think, what are the dynamics at play here? I see university on one end, but what are other things that are contributing to this? For sure, we've got the pedal to the floor on driving, technology forward and faster, smaller, cheaper, that's relentless. But what else is sort of driving it?
Well, I mean, there's a couple things. And we've talked about the fact that I think that one of the disservices we're doing to students is we don't teach them to make measurements. So most of the measurements that we're making that we make decisions about are bad. And that's part of the reason I wrote my book, Power Integrity. I didn't want to write another book. I had promised my wife I wouldn't do it because she always suffers the brunt of it, but I was going to write another book, and I didn't do it because I wanted to write a book. I wrote it because I was really mad. So much data shows up on my desk that's terrible. But I'll tell you, I run around to companies, and one of the most fun is I go to Google, and you walk in the door, and the first thing I feel is like I'm the oldest person in the building, right? And there's really smart kids there, really
super smart.
With no wisdom, right? They have no experience,
that's it.
But they're brilliant. They don't have somebody providing that wisdom. So my own company, I like to put old guys and young guys together, and they kind of cross-pollinate, and that's a good thing. But they're kind of missing that little piece of it that I guess you just call wisdom.
Yeah.
But we haven't seen nothing yet. I mean, the wideband gap is just starting to come now, and people don't understand what wideband gap means. You'll see our scope calibrator. We're switching gallium nitride. I think we hit about 700 volts per nanosecond in our probe calibrator. So we're switching 100 volts at 130 picoseconds. And I mean, you can see that everywhere. It's going to be EMI, it's going to be SI, it's everything. And then you go to try to figure out, how am I going to measure that? Alex Ladeau is a good friend of mine. This isn't his first rodeo. He also invented the MOSFET, which I swore nobody would use. And I recently had a discussion with him. I told him, it turns out I'm actually right. It took a little while to get through the transition. Everybody's going to be using gallium nitride. Nobody's going to be using MOSFETs. It just took 40 years to get there. But Alex always asked me, how fast is our device? And I probably make the most measurements on wideband gap. I wrote a paper in 2015, and I published a paper at, I think it was 250 picoseconds. And Alex was all excited, and he said, wow, my device is 250 picoseconds. I said, no, your board is. No idea how fast your part is. And I sent him this picture. I said, look at that, 130 picoseconds. And he said, holy cow, we don't have probes that can measure that. And so Langer EMV is going to be at DesignCon, and they're going to try to validate a measurement that I made using an air cavity. And I just absorbed the EMI out of the gallium nitride, and I absorbed that into a waveguide. I put it on an oscilloscope, and I was able to create a time domain picture of the waveform so I could measure the pulse edge. And Langer is going to try to validate that measurement for me at DesignCon. I got a challenge from another friend, and he gave me a part. It's a little voltage regulator that's sealed. And he challenged me to make a high fidelity model of this part using nothing other than a near field probe. And I'm almost finished, and he's asking, how did you figure out what the turns ratio of the transformer was? And I said, you don't understand. Everything is coded in those signals. I gave him a picture of the drain waveform of the MOSFETs inside the package. And you can even see what the amplitude of the overshoot is, and that they're clipping their MOSFET. So it's kind of overstressed. And it did all of that with nothing other than a near field probe. So when we start getting to this gallium nitride, 100 picosecond edges, and we keep squishing stuff closer and closer together, oh my God, it's going to be an entirely different world. And what I'm telling engineers today, if you don't understand RF and microwave and analog and power, you're going to be irrelevant.
Yeah, and I so get what you're saying, and it really is the perfect storm. And, in about the time you actually started Picotest, I started working for a little tiny RF and microwave shop called Transline Technology, and I'd always done, high layer count, complex boards, whatever. And these two sweet Indian guys that know a ton about making RF boards taught me a ton, and man, I had no idea. I used to tell people, I go, you have no idea how many ways we could screw up your board.
Oh yeah, so easy.
I mean, it's like the copper roughness, the thermal excursions, the blah blah. I mean, there's so many ways that to me it's almost like a miracle any of them ever worked, right? And so
and now go take a look at today's cell phone or today's car. It's got 9 different transceivers running around there, including radars and Wi-Fi and Bluetooth, and and you put all of that inside a little cell phone.
I know.
And making this stuff work is quite a challenge.
I know. And, something I also wonder about, or something I've been keeping my eye on for a long time, and it hasn't come true, maybe like your story of the MOSFET. I keep saying we're going to hit the end of what's possible in making, because the process of manufacturing a PCB, we're coming to etching is an imperfect process, right? Lamination, we can't make it perfect, but what's needed on the board is near perfect. So unless we come up with additive technology, something that really works, where copper smoothness is not an issue, and that you have super straight-sided, repeatable, consistent traces that you can model perfectly. And, I don't know. I just feel like we're going to get to the end.
Eventually.
But I've been thinking that for 5 years or 10 years, and I keep thinking something's going to give. Someone's going to come out with some innovative thing, but
there's still people doing crazy things. So
they do.
you look at the gallium nitride devices that Alex makes, and they have 15 mil pitch, but they're super high current devices and they're minuscule. And we were trying to figure out how we're going to do the upcoming projects that I'm not ready to talk about yet. Well, and we found a printed circuit board company in Japan that's doing 15 mil pitch with 50 ounce inner copper layers.
What?
50 ounce copper.
What?
On inner layers at 15 mil pitch. It seems like they just keep rising to the challenge.
It's true.
In fact, if I remember, I'm going to pack some of the samples that they gave me. They came here from Japan to talk to me and show me this technology that they're doing. And they're doing 50 ounce copper inner layers with 15 mil pitch. Crazy.
Crazy. I actually worked with this engineering firm once, and these two guys I work with, they're crazy. Well, they did a lot of work for the Lockheed division, the Skunk Works division of Lockheed. And so if these Lockheed guys were coming to this little board shop in the middle of Anaheim with these two guys in this small shop, but they were pulling out unbelievable work and just almost using us like their personal lab. And so we did a board once that I think had 5 ounce copper or something. It was crazy to me, but we did it, and it was like, 5 ounce copper. So I can't imagine 50. That's nuts.
Yeah, it's pretty nuts. And I think that the other thing you have to look at is it's not going to be okay to just get it done anymore. It's that we really have to optimize everything, because we have to fit more into the space. We have to keep the costs down. We have to just keep ratcheting it up. It's not going to be okay to just make it work. It's really going to have to be optimum. And that's going to put a lot of pressure on engineers. Engineers are under crazy pressure now, but it's going to get worse, much worse.
The thing that I've observed, and actually I've spoken to university, I spoke to Michigan Tech last year, and one thing that I told him, okay, here's what you need to know to get a job. First of all, you're going to have to learn to actually design a circuit board before you graduate, so get busy. And the other thing is, like I said, you have to think like a systems engineer. So start touching everything, mechanical, software, touch everything you can get your hands on, because I've seen slide decks from Northrop Grumman or different companies like, we want you to be, a physicist, an electrical engineer, mechanical engineer, a software coder, and we want you to have social skills and be able to present. It's
that's what I'm saying. This is all holistic, right?
It's like,
so you're going to have
very
to understand
holistic.
Yeah, you're going to have to understand everything. You really will. And there's so many engineers right now that can't get jobs because they don't have that hugely broad knowledge, right? So I think they really are under a lot of pressure, and I think it's actually going to get worse before it gets better. And so I think that if engineers don't know all of these things, they're just going to be irrelevant.
They really will.
But it also means that the world of test has to keep up with it, and just giving engineers more traces is not going to help.
Yeah. Well, thank you so much, Steve. This has been great. Well, and I will be sure to share all the DesignCon stuff, link to Picotest, your books, webinars. Is there anything else you'd like us to share or that you might be of interest to our audience?
That's probably it, other than my next book does come out on Friday.
Oh, okay. Where do you publish, actually?
Right now, we're actually publishing from a very small publisher called Faraday Press,
okay,
who's a good friend of mine. And it actually, he's published my last 2 books, and this one is called Power Integrity with ADS.
Okay.
And it's going to release just ahead of DesignCon. And I can tell you that there's going to be one in the giveaway at Janine's library. She's giving away a library from Signal Integrity Journal, and a copy of my book will be there. And I'll have a few copies running around. So I hope to see you next week.
Okay, and, I'll look forward to seeing you and catching up and meeting some of your super cool, smart friends.
Yeah, thanks so much for catching up today. This was really fun.
Yeah, thank you. It was really fun for me. To our listeners, thanks so much for joining us today. I am absolutely positive you enjoyed this conversation with Steve Sandler, Managing Director of Picotest. Thanks for joining us today. We look forward to being with you next time. Until then, remember to always stay on track.